link out? Because otherwise everyone will go to the old one.
No, I will do it right now.
Okay.
But you can start.
Shall I start? Okay. So, yeah, thanks for coming. Good turnout today, which is good for Berlin. Thanks again, Max, for inviting me tonight. So yeah, we'll be talking about F# and .NET tonight. Before I start talking about me, it's always good for me to know who I'm talking to. So just show of hands here. Who here is actually using F# today in some? Okay. Every year, I've been doing this for like 2-3 years now, and there was like no one the first year, and then the second year was like one person. Now there's like 4 or 5, so that's good. Who here has heard of F# before this talk? Okay, good. C#, VB guys otherwise? VB anyone? It's always one. Oh, that's good. We had some people in the last one that were VB guys, but they didn't want to admit it, so they said they're C# developers. Anyone non-C#, non-VB, Scala, Java, something?
JavaScript.
Oh, okay, JavaScript. Okay, come from the other end. Okay, good. So the title here actually is, when I first started doing this talk, it was about how F# lets us write code that is designed to be correct. So you don't have to spend days writing design patterns and unit tests to get code that works. It's sort of changed a bit now that I still talk about that, but there's lots of other things as well. I think F# has become sort of an enabler for a .NET developer to do more than just write web applications with SQL backends, which is probably the most common use case, I think, at the moment for .NET developers. So there'll be sort of two parts to this talk, really. Just a bit of background on me. I've been using .NET since 1.0, so 13 years now. Now I feel old. I have a company called Compositional IT. I do F# and functional programming consultancy with cloud, mostly on Azure. I've been using F# since 2012 now. I'm an MVP. It used to be an F#. They now just call them .NET MVPs. I moved to Germany in August. So I live in Fulda. I'm doing sort of a roadshow of talks now around Germany, so this is the second one. I'm also based in London. That's originally where I'm from, as you might have guessed from the accent. I've got an email address, like most people. You can catch me on Twitter. I've also got a blog. This presentation's online. I always keep it on there, update it, so I think I'll send the link out later on, so you can come back and look at it later. I'm not sure how long we'll go for tonight. Max was telling me sometimes you guys stay here till 9:30 or something, so I'm more than happy to go for the next 2 hours, even longer if you want, but you won't learn everything about F# in this talk. The idea is that you get a flavor of it, you get an understanding of what it's about, and hopefully you're enthused to go and look it up yourself as well, learn some more, try it out. If you come from C# and VB background, there'll definitely be some things here that you wish you will have in C# today. Some you will get in the next version, and some you probably never will get. I'll try and go through this presentation as quickly as I can, and then we go through code and stuff. 2 things. One, and I say this with everyone, not just people where English is not their mother tongue. If I speak too quickly, because when I talk about F#, I get really excited, and I talk really quickly, just, tell me. If you have any questions, just shout out. If it's a quick answer, I tell you now, otherwise wait until the end. You can try it in German if you want. If not, someone has to translate for me. My German is probably better than someone who lived here for 2 months, because my wife is German and we lived in England for 10 years together. So I learned a bit. So this, I think, sort of epitomizes how I was when I first started coding. I didn't have any formal training. I went to uni, but if you've done any computer science or programming degree, it doesn't prepare you for the real world. So I didn't know what source control was. I didn't know, we had a shared drive where we just had one copy of the application, we copied files in there. And if 2 people changed at once, you had to pass over the desk before you copied the file over. That was what it was like. And I didn't really have any senior developers. I worked for a big national bank in the UK. And we didn't really have any experienced developers. Most of the guys I worked with work as bankers. They moved to development things. So it wasn't a great learning experience for me, but I did my best. And then I sort of had this moment where I moved company. I worked for a consultancy, and I got this book called Code Complete. That one is in Japanese, so unless you can speak Japanese, don't get that one, but I'm sure there's English and German ones as well. And it talks about, has anyone got this book? Okay, good. So this book really talks about how to write good code at the low level, variable naming, method naming, arguments, things like that. And it gives some really good examples of how you can write code that statistically will lead to less bugs occurring, things like scoping of variables. And then I got this book, Agile Patterns and Practices. Has anyone got this book? Okay, great. So this book talks a lot more about component level design. It introduced me to this thing called Solid, and a lot of design patterns that I started using, and also about test-driven development and writing software in an agile way so that you can make changes with relatively low cost. And I really enjoyed this, and this was probably 5-6 years ago. I was a C# developer full-time. And I went through the whole thing of doing unit testing and TDD, and I thought that my quality of software was a lot better, and it was. My users had less bugs, my manager was happy with me, and so on. But I was unsatisfied with the amount of effort I needed to put in to get the results. I had to write unit tests, and I had to do TDD. And I had to know all these design patterns, and if a junior dev came on the team, it took me a long time to explain this to them. And if you write bad unit tests, I think it's better to have no unit tests, because the cost of them is so high if you get them wrong. You might have a test that is green, and in fact it should be red, and things like this. So I started getting into F#, and I got this book, Functional Programming. It's by John Skeet and Thomas Petracek. And it basically is, if you're a C# developer, how to A, start writing code in a more functional style, and B, how to start using F# as well. It's a bit older now, it's probably 3 years old, but it's still a really good book if you're interested in sort of getting up and running. So I'd like to talk a bit about OO quickly. So I think the way we think about object-oriented code, it sort of goes in hand with that book I was just talking about, Agile Patterns and Practices, which is things like inheritance. We used to think was a great thing. We used to think that we should solve everything by inheriting from base class and abstract classes and so on. And we now realize maybe that's not the best way of doing things, and we should use interfaces and composition. And languages like Scala have things like mixins in them, because it's really nice to be able to take 2 bits of code and plug them together and not cut yourself off. We know that state can lead to problems. We know that identity equality is not always the best way we want to compare 2 objects. Sometimes we want to actually compare the structure of them instead. Are there any ReSharper users here? Okay. Do you ever use the thing where you know, the magic button, and then you say implement get hash code and implement I-equitable? That's what I'm talking about. That's what we often want to do, but we can't do that by default because the default is reference equality. If we look at hardware, we know now that we aren't going to get faster CPUs unless we start getting more cores on them. The only way we can start to use them is by multi-threading. Is there anyone in this room that thinks they're good at multi-threading? Okay, good. No fools here then. I'm terrible at it. I really can't do it, and I don't mind admitting that because it's really hard. You spend weeks writing code that you think work, and then you deploy it, and then 2 days later you get a bug in live. And it takes you 2 months to diagnose why it happened, because it was to do with some timing issue of some shared variable, and you can never reproduce it. And it's really hard to work in systems like that. And in general, I think systems are becoming more complex. You know, we have, you know, cloud systems now with distributed data. These sorts of problems that we're dealing with, we weren't dealing with 10, 15 years ago to a large extent. It was often single machine systems, and now that's just no longer the case. So when I talk about functional programming, everyone says to me, oh my God, functional programming is really hard. It's like some magic thing that you must have learned it, you know, you must have a maths degree and you must know all this weird stuff. And it's really not the case. You know, I didn't even do a full computer science degree. I used C# for 10, 12 years, and you know, OO is all I knew. And I use F# now every day. And it really isn't that hard to start using it. So just clear that from your mind. The thing you'll find if you're using C# or DB today with F# is forgetting everything you've learned, basically, about how you go about designing and solving problems. The same way that People here use LINQ now? Yeah, okay. You know when LINQ first came out and you started doing .where over a collection, you had to remind yourself not to do for each in, if this, otherwise that, and create the collection on top. That is the sort of thing I'm talking about forgetting the instincts that our brains have sort of become hardwired to deal with, and to try and forget that. If you can do that, you're halfway to learning F#, really. So what is F# at a high level? It's just another .NET language. It runs on .NET. It boils down to IL. It runs on the CLR. So if you're using C# or VB today, it's really nothing that different. At runtime, in fact, it's the same. It's just IL. You'll see that I've got the blue box for the compiler is a bit bigger. F#, that's because the F# compiler actually does quite a bit of work. If you look at like the IL that's generated from C#, it's often a one-to-one mapping. In F#, you'll often write one line of code that emits maybe the equivalent of 50 lines of C#. So the compiler actually does a lot more work for you. While F# is a functional first language, it's not a pure functional language. So because it runs on the .NET framework, it has to have an understanding of objects. It has to have an understanding of interfaces, because everything on the BCL is object-based. So you can write pure object-oriented code in F#. The difference is in F# to write object-oriented code with mutable variables is difficult. To write functional code in a pure style is easy. The way the language is structured, which is the opposite of in C#. If you want to write stateful code with objects, it's easy. If you want to write immutable code, if you want to do it with functional style, it's difficult. It looks ugly. It's not really great. Some of the things you'll see down here, some of the features you'll see today, so expressions rather than statements, composition rather than inheritance, immutability instead of mutation, functions as values, pattern matching and union types, which are two features that are coming to C# in the next version. It's looking very likely. Which are sort of like how we'll typically reason about cases of data. So everyone says it to me as well, you know, I'm already productive in C#, and it's already got lambda expressions. Isn't that what functional programming is about? Yeah, lambdas. That is one part of it, but it's more than just that. And I would say C# I think is a great language. For an OO background, it's probably one of the best, if not the best, sort of object-oriented language out there, I think. This thing about F# as well, just for maths and finance and science, absolute rubbish. Absolutely untrue. You can use it for line of business applications, and I have done that, and I know people that are doing it today. So, complete untrue. So if you're using C#6 today, you'll know that there are a couple of features that make immutability a bit easier to do. You can now do getter onlys and still assign the values in the constructor. There are some expressions that have now been brought into the language. In C#7, they're looking at tuples as language constructs, which you'll see in F#. They're looking at pattern matching, which you'll see in F#. They're looking at union types, which are like inheritance hierarchies, but a bit more lightweight. Again, you'll see that today. They're even looking at non-nullable reference types. The way they're doing it in C# is, I think, rather than making it a core part of the type system, is to make it a bit more like ReSharper or one of those tools. It's more of a code analysis warning. So it'll look at your code and say, oh, you're accessing this string, you haven't done a null check. It might be null, sort of thing. Yeah.
I think you can mark the types with not a E and
Us?
a question mark?
Yeah, that's right. Yeah, that's how it will be in C#7. Yeah.
So you can mark them if they are null or
yeah. The problem is they've got now is that if the default would be that it would, if you don't put it with a question mark, it will be non-nullable, which is a breaking change to the language. So they were considering having a C#7 compiler switch, which would turn this on in strict mode, but I don't think they're going to do that now. They're just going to make it. So you still will have this question mark thing, but they'll still have this sort of code analysis stage that will check. So you're right, they will have extra syntax, but it's a bit more than that. So when we talk about F#, why would I want to use F#? The sort of the buzzwords and the tagline is to solve complex problems with simple code, which sort of sounds a bit strange. Surely you need complex code to solve complex problems, but in reality, we'll see that because of the way F# is designed, with a really powerful compiler, with amazing type inference and a really lightweight syntax, actually turns out that you can often solve really difficult problems very, very easily in F#. This is a quick testimonial from a guy, Simon Cousins in the UK, who works for an energy trading company. They actually used F# code for their business analysts as a form of spec, rather than writing it in English, because the F# was actually easier to read and understand. That was for business analysts, not for developers. A few other places that are using F# now, so Jet, I don't know if you've heard of them, they're a startup in America, they're trying to take on Amazon. Everything they've written is 100% F# in Azure. So they're an e-commerce platform, website, database backend, the sort of thing that we probably write all the time. Credit Suisse, a very big user in London, investment banking. One of the guys who runs the team used to work on the C# compiler team, and he now works there. So a few different areas there you can see. Just trying to get you to see that it's not about maths and science only. This is a real-world example of an app that was rewritten from C# to F#. Blue are the lines of code from C#, green is the lines of code in F#. This is an extreme example. I'm not going to say every app you migrate will be the same, because there was a team in some offshore place that wrote the C# version, but essentially, from what I understand, they had a lot of bad patterns in there, but it was a team of like 20 devs. It took them 3 years. The F# version was written by 3 devs who'd never used F# before, and they wrote it in 6 months. Yeah. Another example here of another app that was migrated again. Some things that are interesting here are things like null checks, 195 in one and then none in the other one, I think, or maybe 4. Braces takes up almost a quarter of the lines of code in a C# app. You don't have any in F#. So. Last thing before we jump into the demos, I think, just a word on Microsoft and .NET and open source. Microsoft is really changing over the last year or so. They're not there yet, but they're moving to a completely open source model. And I think it's somewhat different from the F# point of view, but C# and VB, I think we've been used to Microsoft serving everything to us on a plate every year, C#5, C#6. This is not going to be the case anymore. We have to, as a community, get more involved with shaping how C# becomes in the future. If you're coming to a user group, you probably are a bit more enthusiastic than the average developer out there. So, everything is on GitHub now in C#. You get the design notes on GitHub every week or two from the compiler team talking about what changes they want to make to the language. So, I think it's important that as a community we really get involved with things like this. The last part about Azure driving Microsoft strategy, that is the most important thing I think now at Microsoft. It's not .NET. Azure is a language agnostic platform. You can write stuff on Linux, you can write stuff in Java and Scala and PHP. It's not all about .NET anymore. So we really have to, if you want to keep writing in .NET, to ensure that it's as good as it can be by really contributing to the community. F# is very different because it's never really had that much support from Microsoft over the last few years. It's really proactive, it's a really open community, very, very different to the way C# works in terms of contributing to the projects. So for F#4, there were 60 contributors. I think only 2 or 3 of them were from the actual Microsoft community. The rest were all the open source community. So it's a very different model. It's already got a strong cross-platform community. So there's already good mono support. There are lots of code editors, Emacs, Vi, and stuff like that. And there are a lot of open source projects out there. So all of these are ones that are like on one big page, but there's actually loads more as well. Type providers. If you guys know Stefan Falkman, he's written this thing called Fake and Packet. They're 2 really good projects as well, open source, and well worth looking into. Just a quick look through some examples of syntax you'll see today. This is a POCO in C# at the top. So we have a constructor, some public getter-only fields and private field. That's the same in F#. So you just define the fields. It will give you a constructor for free. It will give you private backing store. It will give you a public read-only getter. It will also do structural equality built in, so you won't have to use resharper. It will do that by default. So it will generate all the code to do IEquitable and all of those ones, IComparable. Tuples in F# are standard syntax, so instead of having to do tuple.create, you just do and bind that to a tuple. So that's baked into the language. And then you can deconstruct by saying first name, comma, second name equals name, and that will then break it back out again into its constituent parts. A list in F# is again syntax of the language, so it's just open square brackets. That's a list in F#. Don't need to use a library function. What else have we got? I'm probably not going to talk too much about this in the demo, so it's worth just talking about it here on PowerPoint. So in F# we have this notion of sum types or union types. So here you can see I've got a type of direction, which is just north, south, east, and west. And then I've said a type of weather, which is either sunny or raining, which has rainfall, or snowing, or windy, and some metadata attached to them. Now, if you were to do this in C# or VB, you would create a base class called weather, and then you would inherit from them with a different type of weather. In F#, one line here is enough to actually generate a full inherited class. Also, I'll come to that in a minute. Pattern matching is sort of like switch case, but sort of a bit actually usable. So with switch case, you can switch over constants. In pattern matching, you can essentially switch over loads of different things. So you can switch over objects, over lists, over tuples. So here I said, well, given some weather, if it's sunny, then do this. If it's raining and the rainfall is less than 5 centimeters an hour, do something else. Otherwise, if it's just raining and I don't care what the rainfall is, return the string heavy rain, and so on and so forth. This sort of syntax you can sort of build up into tuples, so you can make like truth tables out of. So it's really, really powerful. You would normally have like nested if-else statements. It's also got this thing called units of measure, which is basically a way of attaching type information to numbers. So we can say rather than just my bedroom is 4.1 meters by 2.74 as integers, we can actually attach a type to them in terms of meters. You can't then compare that with kilometers or bananas. It's actually at the type level. And you can see here where I've said like sum them all together and then get meters squared. So it knows how to do that. And you can see on the previous example there, I've said centimeters per hour. So it understands that sort of notion of numerator and denominator. You can make your own ones as well, but it has all the SI ones built in. Okay, that's enough for talking. Let's do some code. Any questions on what I've showed you so far? Just okay. Let's start with a bit of a C# actually, since we're in an F#. So I just want to get you thinking about expressions and statements first before I go any further. So I just want to show you an example method here and try and ask you if you can see anything wrong with this code here. So what it does is it takes a string, which is going to be null, takes a string format criteria, and then depending on the age that we pass in, we're going to then format that text with the length of the string. Just some arbitrary code. It doesn't really matter what it's really doing. But can you see any with this code, how it might go wrong or how it might break?
It might be above.
Okay, great. So we would have to add as else sort of clause here, right? We can say else. All right. That's one, great. What happens if I do that? I've broken my business logic now, the compiler doesn't know, can't help me. Yeah? Okay, so the reason why we're having these sorts of issues is because everything in that if statement there, there's no commonality between those three branches. The compiler lets you do whatever you want. You can actually fix this in C# today by moving to an expression. If we make a function called getText, now the compiler gives us much better support because we can't do this. You get a compiler error. Yeah? We can't do all of this stuff. assigned half of it to age and half of it to the other text. Yeah? Because we're now switching to an expression, the compiler understands much better what we're trying to do. Normally, though, you don't write code like this. You would just do it in line, if else. Yeah. If you can remember that, in F#, everything by default is the second way of doing things. Everything is an expression. Everything has an output. So in F#, an if-then statement isn't a statement. It's an expression that has a result that you can assign to. Yeah. Let's make it a bit bigger. And get rid of Team Exploder. Okay. Right. So let's open up some F#. So first thing we're going to do, because F# is a functional language, supposedly, we'll talk about functions. So to do that, I'm going to just do a quick side-by-side between how you might develop something in C# and the typical development process of developing the same code in F#. Just to give you a feel of the sort of the features in the language and the design methodology. So I've written a very simple calculator class, which has two methods on it in C#, add and multiply, and they take in two numbers and adds them or times them together. So first thing, how would you test this out? How would you try this code out in C# today? What would you do? You've written this class. I want to actually run it end to end. What might you do?
Unit test.
Yep, unit tests. Okay. And if you don't like unit tests, you probably write a console application, right? Linkpad. Okay, great, good. So if you know Linkpad, you probably like what I'm going to show you now. So, yeah, if you don't know Linkpad, then you probably have 100 little console apps in your solution right now that you've used, and you've tried them, and then after a week you haven't kept them up to date, and you throw them away and you make a new one. Okay. So F# has this guy called F# Interactive, which is this window on the right. So this is like the immediate window that you have in C# or VB, but it's available all the time, not just when you're running your app, when you're coding, when you're developing. And you can execute arbitrary bits of code from your actual application and send them to the REPL, send them to FSI, work with it, test it out, and then throw it away. Okay. So F# actually has two files in it. It's got a script file called FSX, and it's got a proper .fs file, which gets compiled into an application, just like a CS file. Yep. Okay. So if I want to make a function called add, we'll say let add, and it takes in first, which is an integer. Yep. Okay. Good. And we're going to return an integer, and we'll say first. So from this, two or three things you can see. One, we don't have curly braces in F#. In F#, it's space. Scope is denoted by space. So if I put it there, then this won't compile because it has to be indented from the function it's part of. Hello. Don't worry, you didn't miss much. I just talked for the last 20 minutes. So, we don't need the return keyword because in F# everything is an expression. The last expression in the function must be the return of the function. Okay. So if I was to say something like console, that's the first part of the function body. This is the last one. So that must be the result that's returned. Yep. You'll notice there that F# is full part of .NET, so I get the full system namespace. It's just like C#. Okay. But we the return type from here. And this code, if I highlight, in fact, let's just execute that just to show you what it is. So I highlight the code, I hit Alt Enter, and on the right you'll see it's been compiled over there. And now I can just type here something like add 5 and 10, and I get the result on the right. Yeah? And then I can assign that to a variable. So now we have this to and fro. I can experiment with some code on the left, try some functions out, try and model out. If it works, great. If it doesn't, throw it away. Very, very easy to get feedback cycles. Normally, if you've got a big application, the quickest way of doing this in C# or VB would be unit tests, probably, because you don't have to go through an entire app manually. This is way, way quicker, way quicker. So yeah, I mentioned here that we can remove the return type. F# has type inference, so you guys know the var keyword in C#. So F# has var for everything, basically. Just think of var being everywhere. So we don't need to return, specify the return type. He knows that because first is an integer and second is an integer, and we return the sum of them. So it must be an integer. And if you look at the IntelliSense that you can see it's still int on the right. Okay. Well, he knows that because first is an integer, and in F# you can't implicitly cast between float and integer or double. You must explicitly do that. That's one of the reasons why it actually reduces a lot of bugs with things like accidentally losing precision. So you have to be explicit in F#. So he knows that this must be an integer as well. So now this function is still int, and int goes to int. And we can actually remove that one as well. And you'll see it's still int. But how does he know that this is an integer? It's not because the function is called add, yeah, which is what someone said to me once. Yes, because you're using the add operator, and add by default will bind to integer if it doesn't know any better. Yeah. So this is still statically typed. It's not dynamic. Yeah. If I now do though, all of these become strings. Yeah, this is not dynamic. This is because now the compiler can see I've used a string. Everything else must therefore be a string because I'm adding them together. Yeah.
But you can still add floats.
No. So if I right.
No, not now, but before you added hello from the ring.
Yeah.
If you add two floats together,
Yeah.
the float will be the result.
That's right. Yeah.
And only if you have floats in your code, the compiler will reduce the. Yeah.
Yeah.
Okay.
There is another trick that you can do, but we'll leave that for now. But basically, yeah.
What you've got in your code, you're using this function, and both in two lines. In one of them you use integers, and in the other ones you use floats. How can the compiler know?
So this is what I was going to say before. So normally the type inference will be defined by the function itself, not by the usage of the function. Yeah. So I haven't called this function anywhere, and we know that it's first and second are integers. Yeah. If I now say something like this, you'll see now that he's actually said first is they're both floats based on the usage within the script. Normally within an app, if I add the 5 and 10 those as integers, this guy won't compile because the first one it's found in the script is a float. Yeah, you can make it a proper generic function though. You don't really have to understand this, but if you add the inline keyword, what this will mean is that it actually becomes a generic function, which takes in A and B, and as long as the operator, as long as A can be added to B, then it will be fine. Yeah, but you won't normally use that, so forget I mentioned that. Okay. Let's switch back to C#. I want to talk a bit about composition. We will compose functions in C# today. So if I wanted to write a function called add5 in C#, this is probably how you would do it. You say add, and I hard code the first argument to 5, and then I call this pass the second one in. Yeah, all with me so far? Good. Okay. In F# it's a bit different. We can do that. Well, yeah, thank you. Okay. F# has this thing though where, if you see here, what we're doing is actually a bit of repetition. We're passing in an argument and then we're passing it straight to the next function. Yeah. So actually, I can just get rid of that. This actually compiles. What he says is you've only provided one argument, but the result is a new function. that takes in a single argument, which is the one you didn't provide on the right. Okay. And you can see the signature over there, taking an int, give me back an int. Okay. You've just learned currying, so if anyone tells you it's really complex, that's all it is.
Can you prevent currying? So you say, okay, I have like 2 arguments and I don't want currying?
Yeah, so what you can do then is F# up. To cut a long story short, you can do it. What you would do is you put them in a tuple form rather than in the curried form. And when it's in tuple form, then you have to pass them both in together. And the same for double. Double's really easy to do. Times 2. Yeah, that's quite good because that got you like 5 minutes to catch your breath there, because I'm sure you were just amazed by that. Okay, so yeah, so we can part these guys and get an arrow. There you go. So yeah, work. So it's code reuse within C# and the OO development practice. So let's say I wanted to do something that within every function, within add and within multiply, I want to print out the calculation I'm doing to the console. Yeah. Bad my C# has become. If it's not Google, then it's Microsoft. If you've not seen that before, that's C#6. You can now do this string interpolation thing. So, all right, very nice. If I want to put it into multiply as well, what do I do? You're not allowed to say copy and paste. Okay. Here's how you do it. If you've read Agile Patterns and Practices, and you know Solid, and you know all of that stuff, this is what you do. You create an interface called iBinary operation. And this guy has two things on it. It's got the operation. Oh no, I forgot to say as well. I wanted to say first plus. Yeah. Okay. Two things. You have operation, which is going to do the work, and you've got property, which is going to say the name of the thing, plus or multiply or whatever. And then you just create them. So we'll create an instance of plus. Yeah, that's what he does. And we'll do another one of times by. And then you make a runner called do, which some arbitrary operation. He takes in the two numbers and he does, yeah? This is what you do. If you've read the books, this is what you'll do. And you'll write unit tests for all of this as well. Okay. If you like C#3 and you like Link and you like your lambdas, you might decide this is not for you. Well, I get rid of all of that. And see what I've done there, everyone? Yeah, so that guy now is going to be a function. At the right side. And then we call it, and then we pass it in. Plus first and second. Yeah. This is probably not how most C# developers would do it, though. If you're lucky, they do the last way. If you're really unlucky, they copy and paste it everywhere. Okay. So I'm going to show you how function. This is how you convert from C# to F#. You get rid of every bit that is meaningless. Okay. That, and we just call it. Result, that becomes that. Get rid of that. The F# equivalent. The big difference is you can guide it with %. So %d is a number, %s is a string, and the compiler will then not let me pass in the wrong ones. Okay. Get rid of that, get rid of that. Hopefully, let's have a look at that signature. Okay, you've done it. Do stuff takes in an op, which is a func that takes in two integers and returns an integer. Op name is a string. First is an int, second is an int, he returns an int. How does he know that? So from printfn, he knows that first is a number, op name is a string, second is an integer, result is an integer. He knows that op is a function because we're passing in two things, first and second. And he knows it returns an integer because it's assigned to result, which we already know is an int. Yeah? Okay. From our function. And the syntax in F# instead of doing the. Okay, nice. But we can actually do better. Sorry, go on. Question? No?
He's complaining.
Oh, that's just a limp warning. I'm not showing you that because if I did, it's going to ruin the next part of the demo. So basically, F# has a lint as well that gives you like guidance on best practices. So we already saw how you can lock off the last arguments and not put them on, and the compiler will figure it out. So we can do the same thing here. Get rid of them. Yeah? You with me? Okay. Lint was telling me that actually in F# plus is a function. It takes in two numbers and gives you back a number. So I can actually just get rid of all of that and just do that. And do that. And then if I want to make divide, well, that's pretty easy. Yeah? Okay. That is the sort of development process I'm talking about in F# that helps us write some stuff. We experiment. Obviously, you're not going to know, the operators and these little tricks by default, but you can really quickly write code that is really succinct. 6, 7 lines there, compared to interfaces and inheritance and God knows what in the C# world. And this is not it is a contrived example, but this is not some magic one-off example. People are writing code like this where you can look at it and the only things you have are the bits that matter and the bits that are different. Yeah. Okay, good. And you'll see there's not one type there. We put one type signature, but it's still completely statically typed, and it's just as strong, if not stronger, than C#. Okay, that's pretty much all the C# I'm going to show you for now. What's next? Okay, so I'm going to whiz through these because then I've got more time to show you the really good stuff. So I touched on this before. So in F#, tuples are just a standard part of the language syntax. So there must have been a million times when you've written a function and you wanted to return 2 bits of data, and you couldn't do it in C#. So you either did an out parameter, and then you got told off by your boss or something, or B, you created a DTO, which had 2 fields in it called A and B or something stupid like that. Yeah? Okay. So in F#, you can pass tuples around just like you would with single bits of data. And he takes in this guy called name. And I'm going to decompose that into a first name and a surname. And then I'm going to print out hello, fname, sname. So he knows that name is a tuple. You've got string times string. And he's figured it out with the same mentality as before, except because I've got this. Why is it shaking? Because I've got the comma there, he knows it's a tuple. It's been exploded into 2 parts. And I can return a tuple as well, so I could say fname, comma, sname, comma, 5. Now, if you look at the signature here, he says I take in the tuple of string and string, and I return back string, string, int. So it's 3 parts. And you can have as many parts in a tuple as you really want. So just with something like that, you find that lots of small helper methods are a lot more succinct because you don't need to write these DTOs. You can just pass around bits of data. But they're not really good for public APIs because you don't have named fields in tuples in F#. You can call them whatever you want. So F# got this guy called the record, which is like, think of that as a C# POCO sort of thing, yeah? You tend not to put any behavior on it. It's used for storing data with named fields. Yeah. So we define it with field and then type, and you can separate them with semicolons, or you put them on a new line. Same thing. Okay. It's worth also mentioning, if you go home and try stuff in F#, the first thing to do before you even open up anything in Visual Studio is download the Power Tools extension. So you go to Extensions and Updates, and then you find F# Power Tools. Without that, you will get no colorization really. It will look like Notepad. You will get no refactoring support. You'll get no lints. You'll get nothing basically. So the Power Tools is an open source community-led project. It's not done by Microsoft, and it has like coloring. It has refactoring. things like that. Go to definition, it has all of that. So if you don't install that, you'll think that Visual Studio is really useless, but if you install it, it's actually usable. So let's move this print name function down. And so rather than use a tuple, I want it to use this record that I had before. Let's call this person, in fact. So the compiler has already realized I'm using person as the type of person. Because I dotted in my typed first name, because I've done that, the compiler has realized, well, there's only one other type in scope that has a property called first name. Therefore, this must be name. And you lose the amount of times that works 100%. 99 times out of 100. And if it doesn't, yeah. Yep. Yep. Then you can specify the type.
I can specify it, but I don't need that at the moment because you can distinguish the correct type.
Yep.
And if there are changes, then we might change the type. Maybe because from one moment to the other.
Depends on what's in scope. Depending on what is in scope, or so if the compiler can be 100% sure that that is the only one it can be, he will use it. If he's not sure, he won't compile. Yeah. So if I make another type now, which has something like this, and I'll call it name 2, and then I just set test or something, and if I get this to compile, you'll probably see here. We'll come back to that later. That should have actually given a compile, so come back to that later. Okay. Anyway, so I have 2 objects of the same type. We'll just rename this guy. One of the things that's quite nice is when you don't actually declare the type names, you can actually just, because you never actually reference the type anyway. But here's Isaac, which has got my name and my age, and then I've got this guy Doppelganger, which is the same one. Okay. So in F#, the equals is not assignment. That's equality. That's double equals in C#. Yeah. What happens if I then ask that? What's the answer? True or false? Yeah, because it compares every field in it. Yeah. So this is the equivalent of pulling get hash code and all that stuff out of the box. If you want to compare it the other way, you can do system reference equals and compare that. I've never written an application where I needed to do that though. I have needed to do this many times. Yep. If you've got an object and you want to change it, in F I want to go here. Okay.
Actually not. You have to fill the present.
Oh, how stupid. It says I'm presenting.
Yeah, you are presenting, but you have to share the screen.
Thought I did that. Yay! That's like recursion, yeah. That's telco recursion in F#. Never ends. Let's risk this. How are we doing, Max? Okay. Yeah. Okay, let's just keep going. So just notice I don't even bother putting in the generic argument editor. Compiler can just figure that out because I'm calling that with 10. But I wouldn't use that because this guy is a list as well, but it's an F# list, which is an immutable list. So you can never remove items from a list. You can create copies of lists with new items added to it, or keep items removed with the original information. And if you've used link, that's the same philosophy, because you start with a collection and you do where, and you do select, and you do group by, and you get new collections every. It's the same philosophy. So if you have a list, you have collection operations that you're probably very familiar with, like average, and count by, and distinct, and all the usual ones. So really simple operations here, like I can say for numbers 1 to 100, square them, then filter ones where the number is less than 20, and then split it, partition it based on whether they're odd or even. And that will then give me back a tuple, which has the odd number and the even numbers as two separate values. Yeah. I've got it backwards actually, it's evens and odds, but yeah.
Is that a lazy list?
No, so a list is easily evaluated. There is a lazy one called sequence, which is basically enumerables that you can yield from within. And there's language support for that very much as well. You can also do arrays, standard.NET arrays if you use the pipe. And that's a standard .NET rather than a list. Okay, this is just to bring us back to what we looked at before. That is the equivalent of the code we had in the C# example. So I have an if-then expression, and I have to return from every branch a string, because it's assigned to this value. So you can think of that guy, basically everything in there as a function almost, that's been defined. It has to return something. So if I then get changes to 1, 2, 3, this won't work, because it should be string, because the other two branches are also returning string. Mm-hmm. Yeah? In this way, the compiler can much better support us. If I miss out that branch, get a compiler eventually, because I've missed out the last case. So I'll just show you async support in F#, which is quite nice. So you guys used async and await? Yeah, okay, great. So async await was basically modeled on F# basic workflows. Everything I've shown you up until now was in F# in, I think, 2005, everything, including basic workflows in F# too. So I have 3 URLs here, and I want to download all of those onto my machine, just the contents of these web pages. So what I've got is a function called download URL, which takes an URL, and I print out the thread I'm on when I download, create a normal web client called download string, and I pass it in as a URI, and then I print out the number of characters and the thread it was on. Fairly basic stuff. And in F# using open. Okay, so if we want to download all of them, this is the sort of way you probably would do it in idiomatic F#. You pipe that into array.NET. So it says, given all these URLs, pipe them in to the download URL function. So I call that, and then on the right you'll see we get all the downloaded stuff. Okay, so that compositionwriting.com is my website. I only just created it the other day. It's the default Azure sort of, this page is still being created, and it's 200 pounds. I don't know what they're creating. But anyway, so you can see that they're all downloaded on the same thread, thread 1. Yeah, and they're all done in series. So okay, you guys know link, and you can do parallel, right? So we can do the same thing by changing that to just .parallel. So if I do that now, you'll see that all the 3 start at the same time, and they're all on different threads. Yeah. Okay. But the problem is, when we look at this, you'll see that all the 3 URL downloads happened, they started and finished on the same thread. So the BBC started on thread 1 and it finishes on thread 1. 19 to 19 and 12 to 12. That's because that thread is locked while it's doing the download. So if you've got a website and you're taking loads of requests a second, and as part of that request, you do some operation like go to a database, go to a file system, call some other URL, and that URL takes 10 seconds, that thread is doing nothing for that time. Yeah? So that is really what async work is about. So here's how we change that in F#, and you can do the same in C# with async await. But I prefer the way we do it in F#. It's a bit easier to reason about. So that's the only time you'll see curly braces is with these blocks. So this guy says all the code in here should happen asynchronously. Okay. Then we change this guy from download string to async download string. And then you'll see the right-hand side now is this async of string. It's like a promise or a task of string. So to get out of that, we just do bang. We do let bang. And that now does the continuation for us, just like async await does. Yeah, and then it's just a string and we can use it as before. Okay, so I'll compile that guy, and then we change this back to map, and then we say async.parallel. So each of these guys, from this one here, will give me back an async workflow, which I can then say run them all in parallel. And then in this case, we'll just block until we get them back. So we'll kick them all off as asynchronous workflows. And you'll see what happens when I run this, if we're lucky. And you can see, for example, BBC starts on thread 19 and now it comes back on thread 20. Because when the continuation occurred, the thread is released into the thread pool. When the data comes back from the web, it then carries on running the thread.
Can you define the thread pool that it runs on so you can distinguish between like blocking stuff, doing IO?
You have some control on that. There's also another one, IPAC, which gives you much finer control of basic workflows. You can also basically, the point here is you can use any task methods as well. So any asynchronous tasks, you can convert to async workflows in a one-liner. So you can use any BCL code, anything in .NET that's using async tasks, you can use that as well. Yeah.
How does the code look like if there's some try catch?
Is there some
problems? Exceptions?
So exceptions you can handle within there. There's basically a combinator which lets you track exceptions of async workflows and then bring them out and deal with them yourself as well. But you can do try catch within an async workflow. So in F# you can do try catch basically like this. So try. Yes. In F# you can also pattern match on exceptions, so you can match on an exception type. So you can say, if this is a type system web exception, do this. If it's that, then do that. Using the same sort of syntax, in fact, the very, very similar syntax to the pattern matching I showed you in the earlier example. No, I think we've done enough of the boring stuff, so we're going to move on to the really fun stuff now. So everything I showed you up until now is basically variations on stuff that you probably already do now, and 90% of that you could do in C#, but it would look really ugly, or just wouldn't be idiomatic C#. The stuff I show you now you can't do in C# because it doesn't exist. So, has anyone here heard of type providers? Okay. Max, use F#. If you didn't put your hand up, I'd be worried. Okay, so type providers are a way for us to deal with data and the language of F# as one. Basically, to bring the two together so that we can generate types from data. Which sounds a bit weird, but I will show you. So, I have here some football results as a CSV file. Yeah, this is unfortunately not Bundesliga, this is Premier League, but you know, if you forgive me. So it's pretty basic, you know, I have dates, home and away teams, some scores and stuff. Yeah. How would you, if you wanted to do some analysis on this in C# now, how would you do it? What's the first thing you'd have to do? Yeah, exactly. So the first thing you've got to do is then file IO, you've got to correct DTO, you've got to do the mapping, you've got to do all that fluff. You can't actually start doing anything interesting until you've got the data into your app. So F# has this nice thing called a type provider. So I want to create a type called football based off that CSV file. Yeah? So I hit that. And then I can load that sample data set and I get this .load property. And then I can do dot. And I get all the properties of the time. Yeah? Everyone knows that. Okay, more than that, if you look at like date, you'll see it's a date time. So the provider has actually gone through the CSV, looked at the first 10 rows, and then inferred the types of every field in that data. Okay. So now if I want to do something like show me the teams that won away from home the most in that season, it's pretty easy. I filter out all the results where the away goals were more than the home goals. Yeah, that's away goal. Then I say count by the away team, which is going to give me back a tuple of team name and the number of occurrences of that. Then I'm going to sort it descending, and then I'm going to chart it for you. So just to show you again, the rapid being quite useful, we'll do this line by line. So, yeah?
What is the double backticks?
So good question. So in F# you can create properties that have spaces or any symbols in them. They don't have to be single words. You just have to put backticks on the front and the end, and then you can do spaces in between. So here, because the columns have spaces in them, it replicates that in the type system. So when I do my count by, you'll see on the right-hand side, I already get back a sequence of tuples. So there's team name, number of occurrences, team name, number of occurrences. In C# you have something like this with group by, but it gives you back an interface called iGrouping of key and value sort of thing. In F# it's just a tuple. So then we can sort it descending based on the second value. So now we have the teams going downwards. And then I can just use this nice library called F# charting. And then results. Yeah? So there's like 6 lines of code. This is one of the areas where F# really does shine because it's just extremely easy to do this with the wrapper as well. I will just show you a few more type providers quickly because they're quite cool. So that is a local system, obviously. That's me using some local data. BBC exposes TV listings as JSON. And it looks something like this. So you get a page, you get offsets, and you get a load of properties on them. TV listings and whatnot. So I can build up this using the JSON provider. And then I can create a simple function that says, give me a string, which is a type of genre, and I'm going to then build up a URI. Yeah. So that %s is where the job will go. And then I can call that get listings for job. And I pipe the result of that URL into the load function of the type provider, which says, give me the URL. I will then pass the JSON for you. So I can do that. And then straight away I get dark and I get the broadcasts. And then I can say, well, filter out only the ones that are repeats for every broadcast. And that's a Boolean, it knows that based on the schema I gave it. And then give me back a tuple for the first broadcast date of the program, the display title, and the synopsis. And then I want to put it into a data frame, which is like a data table almost, so I can quickly view it. And then there are some programs. But that's gone in real time to the VXUO, so I downloaded that. I use the type system from the schema that the sample I gave it, so that I can quickly get the data.
The schema in your example is inferred, right? So it's just you give it a sample and it infers.
So depends on the type provider. Some of them, like the CSV one, allow you to explicitly pass in the column headers and type them. So if you know better, you can do it. But to be honest, even with the schema, you can generate a schema that is explicit to give you the types.
If you make inference on the demo file, you can easily get runtime error.
Yeah, absolutely. You can't stop that. So it's the same issue that you get with any application. It's the same issue you get in C#. If you generate a schema manually with the TTO, and someone starts returning different data, you get it.
But with the schema, you get some expectation about.
That's true.
It's declared, but in this case, you use it like in the code.
Yeah, you're absolutely right. You're right. If you own the data source, though, there's a source. Yeah, you're right. Don't worry. You're absolutely right, though. And that's an interesting point, which is exception handling and dealing with errors as well is something that you need to think about. F# has pretty good support for that because of the type system. You tend not to deal with exceptions and throwing exceptions. You normally return like a results object, which has two cases, the success and the failure. And you pattern match on that to say, if it's a success, this is what I'll do. If it's a failure case, I'll do something. But you're right, you do still have to cater for issues if the runtime data changes. I won't show you the SOAP one, but there is a built-in WSDL provider, so you can point to a WSDL generated schema and do the same thing. I won't show you that simply because SOAP is, old school, and if you use that, not cool. I'm joking. I'm using a WSDL schema. Okay, so the last one I'll show you. Oh, that's why the hangout didn't work. I didn't click the tick box in.
Yeah.
Okay. Okay, who uses SQL at work? Make sure SQL. Okay, good. So, there's also a couple of SQL type providers, and these will make your need for entity framework, in my opinion, obsolete. Since I've been using F# in this type provider, I haven't used entity framework ever, or any other type of framework for data access. So, what you do with this one is we give it a connection string, which in my case is a local database, and we pass in a SQL query. Yeah, select star from table. This is not the same as ADO.NET where you chuck in weekly type SQL and you get injected and attacks and all that. Because if I type in something like that, you see it goes wrong. And it says invalid object name, sales GLT product. It's gone back to SQL at that point and validated the query. Yeah. So I get back this guy gives me a function that will execute that SQL. And when I execute that, I do dot, and I get back all the properties from SQL. And this is guaranteed to be right because this is based off the SQL schema, not a weekly type schema. So all the properties there are actually the exact right property date time based on SQL. If you get a nullable field on SQL, this will be represented as an option type in F#, which is basically like this might be null, it might not be, but you have to handle both cases. So you can't just dot into a nullable value in F#. So here I've taken like name and color. Just look at another property name. So if I do name, comma, list price, yeah, this guy will break now because the result set has only retained those two properties. This is really different from working with something, even Entity Framework, where you have code gen. So if I imagine you're working in a team with 5 developers and all working on SQL, you might have each of you with a local database where you work on in isolation. Imagine that you've got a database project, you check in your schema, and then someone else downloads and upgrades the schema. If they've broken something in code, your code will not compile as soon as your local database is updated, because this query will be built at compile time. So you can't get into that. Huh? Yeah, runtime is going to do the same thing. Yeah, absolutely. Yeah, you'll get that. Again, depends on how the provider handles that. But yeah, basically. But you won't even have to run the app though, is the point of saying, to find out that you've got a problem. If there is a problem that you determine the compile time, you get that right away. Download the database, update your local project. There's a really nice one called an enum provider as well. So how many times have you had like a reference data table and you try to have the same as an enum in code and as a database table, and you try and keep the two in sync, and you always forget one of them? So this guy says, well, you give me a query of the name and the value, and then I just do dot and then that's it. Yeah? And if you start referencing one of these items in your application, and someone deletes that row from the database, your code won't compile. Yeah? This is what I'm saying about, this changes the way that you think about a compiler, because it actually gives you a much richer information about the type system. Yeah? And you don't have to worry about runtime errors for things like this. You catch you much richer. Last one I'll show you here is that you can also use parameterized queries with this type provider. So there I've said, find me all the products or whatever where the price is less than a certain value. So he gives me back a parameterized function that takes in an actual value, and that value is a decimal derived from the type of price. So it's not just for simple statements, you can parameterize this, and it doesn't have to be inline SQL. You can give it a SQL file, or you can give it a store procedure. Okay, let's try this one. Do one more, and then we'll move on to something even more interesting. So there's also the HTML type provider. So let's see how this works. So the HTML type provider lets me connect to any web page and reason about lists and tables. So that means every Wikipedia table you can reason about now, every Wikipedia list. So here I've got the league table for the Premier League again. So hopefully, by giving it that sample, I get tables, and then I get Barclays Premier League. And then, let's go back to the first one, and then I can do dot, and then I get all the columns. I'm not going to bore you with either, but you can see the point there. You can start to work with now not just SQL data, not just with JSON data, with HTML web pages. Start to parse them really, really quickly. I did one recently where I was just looking at, what was it? I wanted to get a list of all the Dream Theater songs, so I went to Wikipedia. You find a table of all of them, just pull them into code, explaining all sort of analysis. It takes like 5 seconds. You just give it the URL and you go. Okay. Does anyone here use Azure? Come on, guys. There must be someone. You know they're bringing up 2 data centers to Germany next year, so if you've got any customers that are worried about that thing, use that. It's the same situation in the UK because the only data center was in Ireland here as well, and they're bringing up 2 there as well. So, see if this works. So with Azure, you have this notion of table storage and file storage, which is basically you can put blobs in the cloud of just arbitrary data and start working with them. It's usually a bit of a pain with the standard .NET SDK, but there's a type provider that someone's written that lets you do things like .containers, and then you can actually iterate over your containers in your blob storage. So I can say like .this, and then I can see all my files. And as I'm doing it's going back to Azure, or if I'm pointing to the emulator on my local machine, it goes to that and says, give me the list of the files in that folder. So I can start reading all these files. You know, there's the same ones before. Get hold of the text, and then let's say read lines or something. So let's see if this works. And then you see on the right, there are all the lines to that file stored in Azure. So it's just, you know, ... and then go. Azure's also got a table store. It supports SQL, but it's also got a very simple table store, which is like a key value pair store. And you do have some schema on it, but it's very basic. You can't do relations, you can't do group bys. But the .NET SDK does support iQueryable, which is a bit naughty really, because you can do all sorts of queries inside iQueryable that will be compile time safe. And then when you run it, it will send that query to the Azure Table Service, which will say, you did something more than just select or skip. Runtime error.
So it won't compile with airplane.
Yeah, basically, it's just compile and then, you know, pray. So the table type provider is a bit better than that, though, because what we can do is generate a query DSL based on the structure of the table. So here I've got a table, and I can say .query, and then I'll get back clauses that have been generated based on the schema of the table. And then I can say where, and then these ones will be based again on the type of data. So for example, if it's a Boolean field, you'll just get equal to, you can't do greater or less than with a Boolean.
But so this is a feature of this particular
type provider. So the thing to mention is type providers are not built into F#. They are a component that anyone can write. They're just standard DLLs that you reference, and the language will then hook into them. So it's a way for you to essentially plug into the compiler. Yeah? And they're written in F#. The easiest way to think of type providers is, has anyone used T4 templates before? Yeah, so they are like that. It is the closest analogy you have in the C# world, except rather than being written in some strange markup language that is really hard to reason about and having to run them on demand, this is plugged into the compiler. So you have much richer support. So we're running really through this quickly. Okay. So I think the last thing I'm going to do is move over to, we'll go back to the slides for a minute, and then we'll go to cloud. So I touched a little bit on there just now with this Azure blob storage business. So I've already said, and I won't belabor the point, distributed computing is hard. It's really difficult. If you get bugs on a cluster of machines, you don't know where the hell you're going to have problems. If one node goes wrong, is it because the software you've written is bad? Is it because the node has gone wrong? Just really hard to do. If you've done, has anyone here done any big data workloads, Hadoop, Spark, anything like that? So you do them, and you have to usually use some sort of framework which has got this MapReduce paradigm normally, and it's a nightmare to do. Or you have to write in like some version of TSQL that's somehow cut down and bastardized, and it's just not a nice experience personally. But more than that, you're leaving your standard environment. You're a .NET developer, you're working in C#, you're working in VB, you're writing with SQL, and then you want to do some other sort of distributed workloads. You have to throw that away, and you have to start looking at another framework, another language, and another. It's just completely, everything changes. We'll talk about that. So there are a number of actual distributed frameworks now for .NET, particularly from F#, but some of them do have C# support. So Orleans is an active framework that Microsoft released, and they did Halo in it. So it's got some decent scale on Akka is a very popular actor-based system in the JVM world, and there's now Akka.NET, which is a port of that. And there's also Embrace, which I'll be showing you now. So Embrace is a very general distributed computer data platform. It's a framework, I should say. And it's written in F#, and by default it has its F# support, but they're actually working with C# API right now. There's a demo someone did a couple of weeks ago, so that they're working on. So let's see if I can do that cluster. So I spun up a cluster while we were doing this demo. So if you want to get started on Embrace today, you basically download the starter kit, you open up this script called provision cluster, and as long as you've got an Azure account already, you basically just have to go down to the script and hit this provision cluster, and it will spin you up a 4-node cluster in Azure and give you back the details for the connection strings. It takes about 6 or 7 minutes. Doesn't take longer than that. Okay. So let's have a look at Embrace. Be careful with this because it's got an option at the bottom to resize your cluster to like 100 nodes or something. Don't do that if it's your credit card in your Azure account. I get like £100 a month free because the MVP business, but even that I only spun this up like an hour ago. Didn't even run all the time. So let's have a look what we can do. So the first thing I want to do is get a handle to my cluster, which is what this config.get cluster does. And once that's come back, I can do things like show workers. So on the right, there are my 4 nodes. Yeah? And those are the generated machine names that Azure's created for the VMs. And yeah, all of them got 8 gigs of RAM and whatnot. Again, though, I'm using this within the REPL. I'm not writing console apps or unit testing. I'm just exploring, trying things out. So, first thing is, how do I do something really simple like hello world? So, you saw that the async block before, which was that guy. So here we have the guy called cloud. So in F# you can create your own blocks. And when we had a let bang before, you can write your own code that plugs in when a let bang gets hit. So here this says, execute this code, but on my cluster. So what it will do is we'll send a message to the cluster that says, anyway, pick this up, start doing it. And the result of this is a process of string, because that's what's being returned from the block. Okay? So I can hit that. Now the cool thing is, and this is a really important thing when you're working with many distribution frameworks, is that Embrace will look through the dependency graph of not only what has been executed thus far, but what is being used by within that block. So if I was referencing a C# DLL, it understands there's a dependency on that DLL. It will then package up the whole thing and send it across to the cluster. And it has some nice tricks, like if it knows you're using the same DLL that you sent last time, it won't repackage it and send it up again. Yeah? So just by doing that, I've now got this ability to communicate and send messages to my cluster and ask it to do computations. So then I can ask it about the task, and I can say, right, what's the state of it? Oh, it's completed, and it took 1.4 seconds to work. And then I can get the result, and you can see I get back my hello world. Okay? So you can think of this sort of cloud model as being like some CPU and I/O and memory that's available for me to call into whenever I need it. And there's sort of a shorthand here, which is like doing .result on task, which is cluster.run. And that says block into it instead of doing the creating the process and then waiting for it. So you can see. So this is beforehand we saw that was just executed by one node, that particular task. Here what I'm going to do is create 10 work items. So I've said for I 1 to 10, create a cloud block. And then return me, as part of that workflow, I'm work item number. And actually, I'll make it a bit better. I'll actually put a machine name as well. System block environment. And then I'm going to say cloud.parallel, which is execute all of those on different nodes and give me back an array of the results. Just like I did with the async.parallel before. Hopefully, if you're too unlucky. Without that working. So while it's thinking about it, we'll wait for that. But the idea is you'll get the results back and they'll all be equally distributed across the machines. So you'll get back, ideally, if you've got 4 nodes and you've got 4 work items, you'll have 1 each of them. Let's move on to house. Oh, there we go. So you can see here we've got the different work items, and ideally you'd see some distribution of the machine names as well. Yeah. So it's set out the work items, done a sort of a full join, and then waited for the results. The idea here really is that obviously you can use it for something a bit more exciting than just getting hello world. But if you had, 1,000 computations, you can send them all out and then reason about them in code. Wait till they're all done, then carry on with my C# workshop approach. So that sort of illustrates the computation side of ntrace. The other thing it's got really good support for is the data processing pipeline. So that works really well with F#, so we can use type providers in conjunction with this distribution model. So what we will do, I recently I bought a house when I was still in London, and there's this site you can go to called the Land Registry, which basically gives you the price of every house sold in the UK, and you can see it on like a month-to-month basis. It's what all the estate agents use to, evaluate properties and so on. So it looks something like this. You basically get a GUID for the transaction ID, you get the price of the property sold, you get the date, postcode, and so on. So what I wanted to do was do some simple analysis on those prices for the last few months. So I took my type provider, the CSV one you saw already, and now we've got our type for house prices. And then I've got a source, which is a live URL on the Land Registry website, which gives me back the last few months of house prices. Okay. So what I want to do is calculate the average price by month. Nothing more than that. But it's pretty easy. We start with the sources, and then we say turn this into a cloud flow. So a cloud flow you can think of as just a distributed link. Yeah. Basically, we'll say, give me a stream of data that I can then execute declarative queries like where, like select, like group by. But do this across the cluster. Okay. And this HTTP file by line says read by line, and if the file is 100 megs, put the first 25 megs on node A, second 25 megs on node B, and so on and so forth, so you get distribution across the cluster. Then I'm going to parse the rows using my CSV type provider, because up until that point it's just the raw strings. And now we're going to convert them into the types that we can reason about. And then I'm going to call this my average by key, which takes in 2 functions. The first is what you want to group on. So in my case, it's a tuple of year and month. And you'll see on the row there, I get, obviously, because it's a type provider, I get all the properties. But this is being done in a distributed fashion. And then I want to get the average of the price converted to a float. So the price is actually an integer, but because we want to get more accurate results, I'm going to convert it to a float. And all this is going to happen across the cluster. Then I'm going to sort it, get the first top 100, push it into an array, and then create it as a process. Hopefully we'll have it quick this time. The important thing actually here to think about though is that even if my Wi-Fi on this machine is really slow, I'm not doing the downloading. It's the 4 nodes in the cloud that are going to download the file. I can actually be doing this off my phone network. It wouldn't make a difference because I'm not doing any of the work. And if we look at the actual nodes, hopefully you'll see that that's actually pretty low for performance. The idea would be that you get pretty good network downloads, obviously not very good there. But the idea would be that normally on Azure, the VMs have got like 3 meg download speeds. So if you imagine that it's not just distribution of compute and data, we can use this for distributed I/O issues as well. If you've got large data sets you need to download into Azure, for example, AWS, you can split that download across 4 nodes and then put the files together at the end when they're local. Oh, it's already done. That's one. So there's the results. So you can see 2012 January, £230,000. And now I've got that data set in memory, I can do some stuff with that, charting and whatnot. But I haven't had to download 100, gigabyte of data locally. Just have to get the final results. So, I won't show you this guy. We'll try. So Embrace has got one other nice feature called persistent cloud flows. So let's say you've got some data set and you're doing repeated calculations on it, 5, 6 different operations. It can take a cloud flow and say, actually, at that point, this checkpoint, persist the data that you've got there across the cluster and give me a handle to that persistent sort of reference. And then I can repeatedly do queries off that. You won't have to download it every time again and again because it's persisted that in memory. And you can back it to the cloud storage as well if you want to, so you can rehydrate it later. So while that's working, so the idea here though is once you've got a handle to that persistent data set, I can then start doing some operations like get me the number of rows. It's not going to have to download the whole file again because it's already got it in memory. It's just a simple count operation. Or I can take the first 100 rows. Again, very quick operation because it's already persisted it. Oh, there we go. So now it's persisted that set. You can see here on the right, we have element count, 81,000 rows across each node on the cluster. So it's actually done an equal distribution of the data set, and it's all in memory. And you can see the size, that's 10 megs. So it's not a big data set in this case, but it could. Okay. So we can start to do more things though with this persistent data set now. We don't have to re-download it every time. We can do things like get me the average prices by town, district, and street. Yeah, it wasn't have to download the whole data set again. Just group up that data set that I've already got, perform another calculation on it. We might want to persist that data set and then do further calculations on it. These persistent data sets don't go anywhere. They'll stay there forever. I'm not going to bother. Okay. Right, I've got some time to show some other demos, but I want to know if you guys are happy to stay for a few more things. Yeah? Okay, good. So what I'll show you then is unit testing. If you're interested in how does that work in F#, maybe? Yep, okay, good. So
The answer is, by default, it's actually really similar. So you can use all the standard frameworks that you've already used. You can use Expressive, you can use NUnit, right? Just to prove to you, here's what I prepared earlier. So, there are some tests in XUnit. That's a method in a module, which is like a static class you can put in C#. Fact attribute on the top, just like you would an XUnit, off you go. So equals. No different at all. In fact, this is one of the easiest ways that you can start using F# in your organization. Is if you want to start writing unit tests for existing C# code, there's no reason why you can't do that in F#. And indeed, one of the nice things is because we've got these backtick methods, you don't have to worry about, oh, do I do underscore or do I use some other convention? You can just write in the name of the test as human readable German. Still not human readable for me, but. So let's see if I can find the test explorer. Maybe it seems, yeah. So what's quite nice is because we can do these backtick methods on modules as well. You'll see the actual name there is calculator unit test because I've called the module with backtick methods. So it's actually reads like normal English. There are a number of wrappers around XUnit and NUnit, which give you a DSL style experience for working with unit tests. So instead of assert.equals, I can say result should equal 15, or should be greater than 11. Yeah? And it's mostly because of the fact that you don't need to put brackets around every function. You can start to chain together these nice DSLs. It's just a wrapper around assert.equals, so nothing more than that. Okay. Another nice framework is called unquote, which gives you a custom operator, which is assert equals. So that says if I do add 5 and 10, it should equal 50. Yeah? It's just a custom operator. Don't think of this guy here as the equivalent to not equals in C#. It's not that. It's the opposite. It should be. So right. I'm actually just going to change the color here because can you read that sort of? Yes, okay, right. So F# has this thing called a quotation, which is what these blocks are here. And they sort of allow you to build expression trees or equivalent of that just by grouping it with this strange little symbol here. So what unquote will do is, if you look at this test here, I'm saying add 5 and 10 plus 99 plus 10 times 2 divide 2. Should equal 14. Yeah, it's just a Boolean expression. Now, I'm really bad at operator precedence with maths and .NET. So if we run this test, and it's obviously going to fail. Because all of that doesn't equal 14. What is really nice is when I pull this guy up, you'll see some interesting output here. What it does is it takes the expressions and breaks them down step by step by step. So you can see where it's gone wrong. Yeah, so right, well, that boils down to 15 plus 19, 9 plus 20 plus divide by 2. And then I can see, well, the operator precedence was clearly times because then the divide happened second and that was 10. Yeah? So you get this nice step by step analysis of what happened with the unit test. Another really nice framework is called FS-Check. This is a property-based testing framework, which is a bit different. Has anyone here heard of PEX? So this is like this thing that came out of LSR, which is basically like generating tests based on code analysis, looking at like corner cases. FS-Check is somewhat similar. What it does is you give it a test that is parameterized, and it will generate values for you. And you can control what those values are. And it doesn't have to be primitives like it's here, first and second are just integers. They can be full .NET objects, business objects. And it will generate variations for strings, for child nested graphs of objects. It will do it all for you. So you could test entire business logic cases by saying, well, I expect this to be a customer that has either values of 1 to 5 for their credit history rating. It will generate all the different permutations for you. So if I actually debug this unit test, you'll see here we've got the values -1 and 0 as the first test. And then I can hit F5, and now I get -1 and -1. And it will go through and generate all sorts of dummy values for me. And it can be used for more than just sort of brute force testing. So, give you another example. So I did this thing last year. F-Shop Community's got this really nice thing. Every year they do the Advent calendar, which is basically every day in December someone in the community does a blog post about something. So last year I did, I basically implemented the Enigma machine from World War II in F-Sharp. And it was actually quite an interesting little challenge. It's quite cool the way that the code turned out. But I wrote a load of unit tests for it. And it's quite interesting, like some of the tests I did were used FS-check, and it was things like, right, well, if you encrypt and then decrypt the text, you should always get the same thing as the input. So FS-check can generate all sorts of random data for me to prove that's the case. Yeah? Or things like, one of the things that Enigma said was, if you encrypt the text, it will never give you back the input text. Well, if you did that as a unit test, how would you prove that? You'd probably do some white box testing. Here it will give you, 1,000 different types of text to give you confidence that it's actually behaving as you expect. Yeah. So definitely, and FS-check works in C# as well. You can use that today. So I encourage you to look at that. Very, very quickly then, well, it doesn't have to be quickly, but who here uses NuGet? Yeah, that's confusing. So NuGet's great. It did a lot for the .NET community. Really helped us to start sharing code and distributing code, but it does have some issues with it.
Go on. It's no problem. No sign.
So yeah, I have to be careful what I say
No.
about the NuGet packet. So NuGet has it does have some issues. Like one of the things it has a problem with is that it allows you to have, if you have a dependency across 2 packages in the same solution, it doesn't stop one getting out of drift from the other. You can happily upgrade one package in a project and forget to upgrade the other one. And you won't find out until maybe you run the app and you get some binding indirect issue or God knows what. Or if you have a really big solution and you have 2 solution files in the same folder, there's no way to keep the 2 in check, really. It's very, very difficult. So this guy, Stefan, he started writing this project called Packet, which is basically designed to supplement NuGet. It uses the same NuGet packages, but it has a custom tool. It doesn't use the NuGet client-side tooling. So it makes some differences for you. Firstly, it says, by default, your dependencies are always shared across the solution. You can't have different versions of the dependencies across different projects. So you basically start with a simple text file that says, right, that's my source, which is NuGet, and I want these 3 packages. That's it. You have the add-in for Visual Studio, you hit install, it downloads those packages. It will also look at the transitive dependencies of those packages and download them all as well, but you never see them. So for example, here I said, right, I want fscheck.xunit, which has a dependency on xunit, but I didn't have to say that here. If I look at the log file, which is like the internals of Packet, you'll see the whole tree of all the dependencies that it has, and it works them out, so there's never any incompatibility. So if I try to download another package which had some requirement to say, well, I can never use, so for example, I'm using fscheck, which says, right, well, this guy must work with fscheck greater than or equal to fscheck 2.2. But if I had another project that had a dependency that must be less than this, it would give me an error. And it would work all of these things out, and or it would fall back to the minimum version that satisfies everything. And it's got some really smart algorithms to sort of do caching. For example, if you have 5 solutions, it will cache the dependencies in your local apps folder in your profile, and then the other one won't have to load them from you again. It'll just get them from your local file system cache. So it's really useful with things like that. And yeah, definitely worth looking at if you've got large solutions and you're having trouble with it. We encourage you to look at the packet. Anyone here doing web development? Yeah. Web APIs, anyone? Okay, good. So I'll just quickly show you some stuff there. Let's see. Projects. Okay. So you can use Web API, ASP.NET Web API out of the box with F#. There's no problem with that at all. The only issues you'll get are things like ASP.NET for the MVC framework doesn't really work with F# because it relies on things like Razor tooling, which has no support for F# in the Razor markup. But there's nothing to stop using C# or VB as a thin veneer on top of your app, just for your input controllers, for your web pages, and then delegate everything to F#, which some people do. Yeah, there is actually, I'll show you a couple of links after I finish the code demos for some really good pages if you're interested in DVD with F#. There's a really strong story for that. So this is just an example of how you can use Web API with F#. So has anyone here used Owen or know what Owen is? So it's like a really lightweight stack for Web API, well, which Web API can work with. So here I've just got a program, a normal console app, which starts by doing web app.start, and then I have my startup class, which is just a regular class. It's not even a module. Takes in an app builder, and I do some stuff here with JSON formatting and turn off XML. Probably the same stuff that you probably do now in C#, and then I just call use Web API. This is the standard Web API framework. It's nothing F# specific. When I want to create a controller, it's pretty much the same as what you normally do, except it's probably half the code. So a class in F# is basically type, the class name, and then the constructor. One of the nice things you get with the constructor in F# is if I say name string, you can use that constructor value in all your methods. It basically will, behind the scenes, create a backing field and copy it across the gun. Normally do that as the same thing. But here I can, within any of my methods, I can just start doing things like names or that. So all of those guys are methods, controller methods, and because of the way that ASP.NET routing works, it just works. That's a get, so I'll go to that guy. And the nice thing is that JSON, Linux JSON works with F# as well. So serialized, deserialized records, discriminate unions, all of that works out of the box. So that's sort of, if you're used to a Web API, then you can start using that tomorrow. I've done entire systems with Web API in F# all the way down to SQL, back again using type providers. It's really nice experience. But there's also another project called Suave. Which is this lightweight sort of F# functional first API driven thing. So has anyone used Nancy? So it's sort of similar to that in the sense it's very lightweight with like root control and so on and so forth. So just to give you an example of what that looks like. So you basically have typically a function called handle root or something like this, which says, right, find me a root that matches any of the available inputs here. So if it's just slash, then give me back OK, hello world. Or if it's slash values, then if it's a get, then return back this list 1, 2, 3 convert to JSON. Or if it's a post, then print out the string got a post or do something more than that. This is really nice. If you've got like query strings with parameterized roots, it gives you strong typing. So if I pass in like value /10, I can have a function that handles that, and it knows that ID has to be an integer because of the root. Whereas here I'm saying, like, give me, human /string integer. So name is a string, age is an integer. Yeah, really, really lightweight. It's completely asynchronous, non-blocking. Really lightweight, easy to use. To start it up, you just call start web server, and then that's it. So definitely worth looking at. There's a good story for sort of the web API side. Let's switch back to here because there's a few more bits and pieces to talk about. So I'm glad I talked about those three. Canopy is a web testing framework based on Selenium. It's a wrapper around Selenium. Does it in nice DSL. I'll show you that very, very quickly. Okay, I showed you already. Fake is an F# DSL that's almost like make. I'm sure Max can tell you a lot more about it. But essentially, it's an F# DSL that can replace TeamCity or Appveil or any of your sort of build servers. It's got building tasks for things like kicking off MS builds, running MUnit, XUnit, setting up pipelines. So after the build, then run the unit test. But if that fails, then run this. And it's a really, really succinct DSL. Someone you don't have to even know you're writing F#. You just write normal code. And the beauty of it is because it's on .NET, if you need to fall back to anything more complicated than what is out of the box, you can just write normal .NET code and plug it in. So things like if you want to do replacement in app config files with key value pairs and stuff, it's got helpers for that out of the box. Really, really nice. Another way you can start using F# is things like small areas of your domain. If you want to do sort of pure business logic, give me a number, give me back a string sort of thing. Something that is very small, doesn't connect to other systems maybe, is a sort of a low risk way to start doing it. F# is just a project in Visual Studio, a file add new F# project, you can reference it from C#. And it's got a good interrupt story. In fact, I'll just show you that very, very quickly. So if you remember the calculator code that we did before, if I try and reference that from my C# code, just looks like a normal class with methods. You wouldn't know that you're calling F#. If I want to create that person guy that I made before, that's just a normal class, and it has a constructor in it, which has the fields that I defined in the record. Yeah? And if I decide, well, actually, I want a non-default constructor, and I don't want it to be forcing me, you just put an attribute on the top in F#, and then it will generate a default constructor as well that allows you to code it in instead. But by default, it won't let you do that. It forces you to provide all. So in terms of interop, if you write many functions, records, modules, you can use it really easily in C# or VB. So in Canopy, it's got a really nice DSL. So to start Firefox, you type start Firefox, and that will launch the browser. And then you can say URL, and that will then navigate to that URI. And you can check that the welcome element is equal to welcome, just like that. And this is just all because it's from a script. You can just execute arbitrary bits of code and try it out and make sure your website works. Really, really easy. And it's just a wrapper around Selenium. It's just done in a really nice way. Click button, clicks around. So you wouldn't necessarily know you're in F#. It's just really, really easy. You can also talk to other non-.NET languages with type providers. So there's like an R type provider. If you've got like stats guys in your companies, you can call R from F#. You wouldn't know you're necessarily leaving F#. Just shows like a module, and it's got like interrupt for the types. Just to wrap up, to show you a few links. So first thing, fsharp.org is like the go-to place for F#, so it's got everything there. Some guides, some good testimonials, some lists on how to get up and running with F# on all the different frameworks. It's important to know as well, there's a good mobile story for F# with Xamarin as well. There's also a cross-compiler called FunScript, which lets you write F# code and it will cross-compile it to JavaScript. And it will also use the TypeScript, definitely typed NuGet packages to give you like strong typing over all the available sort of JavaScript libraries out there in F#. This is probably the best site to go to, F# Fun and Profit, if you want to get a sort of a real-world view on writing F# code and you come from a C# or a VB background. So it's got really good articles on domain-driven design, functional design patterns, real-world uses of all sorts of different sort of patterns. It explains all the stuff that you get like the Haskell guys talking about, like monads and stuff. Actually makes it sort of understandable for the person like you and me, really. So definitely, if there's one site you look at on F# after F# org, this is the one that you should look at. And it's got this wonderful article about why you wouldn't want to use a statically typed functional language. Like you don't want to follow the latest fad, because that's why you picked IT, you don't want to learn new stuff. Or the fact that functional programming has been around for years. If you're a contractor and you get paid by the line, don't use F#. You'll be headless. Yeah, don't use it. If you love curly braces, if you like to explicit, and this is actually, it's a bit of a joke, but it's true. There are some people I know that don't even use the var keyword in C#. You know, if you are like that, don't use F# because you will have stuff like that go into just that.
Is that something that you do in production code, that you leave out a lot of the type annotation?
Yeah, so that's a good question. There are some people I know, people that are well known in the F# community that explicitly annotate everything. Personally, I never do. There are some drawbacks to that, in that debugging or compiling applications can be a little different, because if everything is inferred, you can break code in one function because you change the function in another place, because the whole type inference system bleeds all the way, and then you get an error and you're like, I haven't touched that file for 3 months, why is it breaking now? And then you realize why. So sometimes you'll put in explicit types temporarily to guide the compiler and trace down where an error is. And it also lets you refactor much more quickly, because if you've got a function that returns an int and you want to return a string, you just change it off you go. And the only places that will break were the places that would have had to break anyway.
In other languages, sometimes they do like public API.
You've got that as well.
And internally, they don't.
So the important thing is, it's a good point. When you know all the type annotation and the inference is all at edit time. Once it's compiled, it's all statically typed with types. You can also have signature files where you can actually explicitly say what the contract of a specific file. It's almost like a header file equivalent. You don't have to use them, but you've got that as an option. What else?
And you can generate them from.
Oh, you can generate. Okay. So yeah, F# Power Tools does a lot of things for you. Like, is it Power Tools?
No. It's actually the compiler that generates.
Okay, fine.
What about compiler performance if you use a lot of typing files?
So I think that the F# compiler is slower than the C# compiler. That is true. I wouldn't say it's massively slow, and it's certainly not been an issue for me in terms of writing real-world applications. It's more the difference between half a second and 0.7 of a second sort of thing. It's the same sort of thing. Well, not the same, but you know, when you work with immutable data, you know, you're copying and updating, you're not mutating data sets, and some people ask, well, is that a performance issue? If you've got a time loop where you do 1 million iterations every second and you're creating copy and updates, that may be a situation where you don't want to use an immutable list and an immutable object or something like that. But for everyday coding, I've never seen a problem work with immutable lists and immutable data structures. Yeah, this is actually a good point. If you like the debugger, you know, I write entire apps and I barely use the debugger anymore. I really don't, because the REPL lets me test everything I want to before I run the code. And F#'s type system is strong enough that when it compiles, I'm usually confident that it's going to actually do what it's supposed to do, rather than having to resort to unit tests. And it's sort of you know, unit tests have two sides to it, but one is about trusting your app. With F#, you delegate some of that trust to the compiler because it's a lot stronger than in C#. You don't have nullable types everywhere. Discriminated unions let you be much more specific about what your application is doing, and you deal with every case through pattern matching. Design patterns. Do you use design patterns, Max?
Yeah, sure. Functions.
Yeah, exactly. And it's true. I think design patterns are a great thing because they put some sort of constraints on your application in terms of how you write about them and how you reason about them. That's because in C# or VB, the pit of success is really small. It's easy to write bad code and it's hard to write maintainable code. And often you don't know this until you get to the very end of the system and then you have to make maintenance changes. In F#, it tends to be that your code sort of falls into the pattern of being done in a good way. You can write bad code, of course you can, I have. But you don't have to worry about being a slave to the dogma of design patterns and having factory. You know, an interface with one method on it is an F#, it's just a function. Why do I need an interface around it? It's just a function signature. All these sorts of things you just don't worry about. And if you just learn to trust the compiler and the type system in F#, you can get so far without having to worry about any design patterns. Simple. Yeah. Yeah, and please don't think this is too mathematical. Nothing can be further from the truth. Yeah? It's just another .NET language that happens to have a really, really smart compiler. So, yeah, with that said, and there's loads of user groups. There's apparently one in Berlin as well, I've heard about. But there's loads of it, and it's a really rich community. Hashtag F# on Twitter. There's always someone happy to help or point you in the right direction. It's a really active community. It's small, but it's really friendly and active. So yeah, questions?
You're gonna this presentation be posted? I will.
Yeah, I'll send the URL to Max. Yeah,
sure.
So, yeah.
Right.
Yeah.
What's the story with the input operators and overloading? Is there a way to overload input operators?
So you can create your own input operators. I'm not sure you can replace the standard ones.
The plus or
Yeah.
something like this?
Yeah.
You can actually you can write your own static methods in your class, which will do this operation, and it will be looked up by the default class operator.
The question is more: can I define my own, or is it restricted to like the few that are known?
No, you can create your own ones as well. It's like when you saw that canopy in the testing, that's just your own operators. It's just open brackets, operator, close brackets equals. It's just a function. And that's what plus is. It's just a function. F# also got sort of limited duck typing, where you can specify a function that takes in some T, where T has constraints of these methods must exist on it. But it's a bit inconsistent. Nothing else? Okay.
I've seen some code with like some ticks on generics. What is that?
Yeah. Okay. So I actually didn't touch on that. I'll show you that quickly. So let's find. Great. So you can do generic functions in F#, no problem. If we go to our tuple guy. Right, so this function here takes in A and B, yeah? And I'm printing out A, and he knows it's a string because I'm printing it out with %s, but he doesn't know what B is, because I haven't defined it. So if you look at the signature, you'll see B is of type tick A, yeah? That's the F# syntax for T in C#. So in F#, if you don't provide any guidance to the compiler and you can't see what type it is, you will make the method generic automatically. Yeah, so this is like writing a function, do something of T, and then saying B is of type T. You just didn't have to do it in F#. You can explicitly do that, so I could say this. The same syntax, but F# will do it for me.
With a tick. With a tick.
Use the tick, yeah, correct. Use the tick. I think you have to use the tick, don't you?
Yeah, you have to.
You have to use it. The nice thing is actually he's even smarter than that. So if I said like I'm going to create a list of items which is comprised of B and C, he knows that B and C must be the. Why does he do this strings? He knows that B and C must be the same type because they're part of the same list. But if I don't do that and just say, you know, yeah, do something like this, they'll say, well, I can't prove they're the same type. So B is of type A and C is of type B. We'll make two generic arguments. You know, he's really smart when I can say stuff like let A comma something equals name. So he knows that name is a tuple of string and something. Yeah. And I can then do, well, actually it's a three-part tuple, but I don't call it a two-part. So, yeah. That's where the type inference system is a massive time saver, because you don't have to bother with that stuff. It just makes everything generic and makes it easy. It makes it just work. And 99 times out of 100, the type inference system will be smarter than you are about what the best way of defining, you know, what the most generic way of defining your functions are. Things like you might have functions that you wouldn't even think to make generic. Like let's say you have, I take a tuple and I want to reverse it. You might have thought these are two numbers I want to flip. But in reality, well, why do they need to be two numbers? I'm not doing anything with them, just make it generic. So it changes a lot about how you think about writing code.
What's your experience introducing F# into teams of C# developers?
Yeah, so like I said, start slow. Don't throw everything at once because people get turned off to it. In my experience, they'll say, "Oh, where am I typed? What is this? What's this partial application? It's rubbish. Go back to it." Start slow. Either in some constrained library, maybe you're writing some new code. Try out an F#, interrupt with C# code. And you might find then that my natural experience is it bleeds out from there. Like you'll create a record type in F# very easily, and then you use it in C#, and then someone else wants to make a DTO, well, let's do it as a record in that library and start using it for C#. Or discriminated unions, like that weather example I gave at the start, they're so simple to write in F#, and there's so much effort in C# with class hierarchies, it will just start to grow naturally from there. Other things like testing frameworks, fake, so for your build tasks, they're really nice ways to do it because they don't force you to throw away everything. And I wouldn't recommend throwing away everything. Don't stop with your existing code base, but consider certain parts of it, particularly if you're dealing with, you know, disparate data like JSON and CSV, you know, SQL or something like that, and you can parse it so easily with type providers. Yeah, makes sense. Yeah. No, go first. You've already had your questions.
It's okay. It's short. You say you can define a record type in F# and then use it in C#. But you said F# has mutable types, which would mean if you use that record in C# then you cannot change it.
Right. So by default, a record in F#, when it's exposed to C#, will have a non-default constructor that takes in every field. And the properties on that class are getter only. Yeah. If we attach, and I'll show you here in fact now, so like this person record, if I put this attribute on here called climutable, that tells the compiler that although it's immutable from within F#'s perspective, let other languages do what they want with it. So it will make getter and setter and a non-default constructor. So you can create it as a uninitialized object. And you need this if you deal with frameworks like Mongo, because they like to hydrate objects by creating a default object and then setting the properties. So you do need this sometimes. And you can do that.
What about it?
Yeah, exactly. So there are times when you need that.
Yeah, but I think for this default one, there will be For the setters, there will be provided methods with blah blah blah. If I recall it correctly.
You don't.
No. It was a proposal.
You're thinking about screwing out unions, right?
No, on this one.
Looks like I did left.
Yeah,
I forgot I'm in.
Maybe not far, but far. A plot.
Right, right, so you get properties for them, and you see they get around those because they're not primutable. If they were primutable, they would have a setter. What's really nice is if you look at this, I go to definition. It won't go to the F# actually. It goes to the C#, like represent the metadata, and you see how much from that one record line you get. So you get person, which implements I equitable of person, I structural equitable, I comparable of person, I whatever. And then you get the default constructor, you get the getters, you get all the hash code. This is why I said the compiler is a bit smarter than the C# as well. Yeah.
In comparison to Haskell, is there anything you miss in F# that is missing because
type classes?
Yeah, I actually have never used Haskell, but type classes is the one thing I think. GADTs are the other one people talk about sometimes. I don't know what they are. That's what people say, but type classes and the big thing.
Okay.
That's the and
unofficially the real polymorphic dispatch. It's also the problem. Yeah, the problem is solved with type classes.
Yeah. Unofficially, I have a feeling they are starting to look at putting type classes into .NET, either at CLR level, probably. Whether that happens or not, I don't know. But that's the one thing that doesn't happen. It's the one thing I think that Scala has that F# doesn't. Otherwise, I think Scala and F# are pretty similar in terms of features.
Well,
yeah.
The plus in the beginning it was defaulted to plus to integer.
Yep.
And the signature said with member requires member of edit or something like that. So this is the type class, isn't it?
That's structural typing. It's,
okay, that's different.
So that's why you inline this function. So here he says that requires member. So that's why I said you can do sort of static duck typing in F#. It's not the most elegant syntax, but it basically says there's a constraint on C that you must be able to add together A and B. Yeah. So this is still a generic function as long as they both can add together.
Yeah. But it's not the same as type classes in Haskell, because you cannot provide a type and put this type into a class into a class of which you are already defined, which you already have defined. You know.
Family type stuff like that.
Yeah, that's type classes. Yeah. It's like the sequence. You have the problem of sequence list and array. You have to provide 3 modules in F# for the same operation. In Haskell, you have only one, which is map, and it's do it for all the kind of data you have.
Yeah, so there you go.
Yes, and if you have another container which will be which will act the same, have the same map method, you have to provide a new one. Okay. And that's the problem.
That's what type classes.
Yes, that's what type classes actually are.
John?
So, is there support like in the platform for tail recursion?
Yeah.
Yes.
Yeah. So that's the one thing that the CLR has had actually from the very beginning. It's got a tell function. So that's the one area that Scala doesn't have because it doesn't have JVM support for tail call recursion. F# does. So as long as you write it in a tail recursive way, you're fine.
Well, Scala does have some.
It doesn't have some, but it does. Yeah, yeah, exactly. It's not. Yeah, you're right. It does have some, but yeah. So yeah, F#. Yes, there was a proposal. I think in F# 4 it got dropped, which was to emit a compiler warning if your code is recursive. It doesn't implement tail. It is not tail recursive. But I think that pushed back. So it didn't happen.
I don't know, but recursion you have to specify that you are recursive. If you want to call yourself, you have to specify it. So you don't have accidental recursion, which we one time did had in C# code. You know, web forms controller, web API controller, get calls itself, and it's crash with Stack Overflow, which is not codeable. You can code this exception, Stack Overflow exception, you cannot code it. And it pulls down the whole EAS process. It crashes completely. V3, W3P process is gone. And you put it in production, you go to this particular URI, boom, the whole application is gone. You don't see it. You don't see it, and it's.
Oh, of course, it will just disappear.
No. I mean, you don't see it. Pretty easy that you call your functions by yourself.
But you wouldn't even get the error. It just will disappear the whole website.
Yeah,
that's great. Excellent. That's good.
It's a real story from production for us.
You can be proud of that one. That's yeah. Okay. So, thanks a lot.